Okay, so now that we talked about zero order reactions, which were pretty simple, and you probably thought the process of that was a little bit ridiculous, but let's get into something first order reactions. So when you have a first order reaction, the rate um, is actually directly proportional to the concentration of the reactant. Again, we're only talking about reactants. We're in rate laws, products don't matter, reactants only. So, because think about as you progress on a reaction from left to right, reactants are becoming products. So that means the concentration of the reactants is decreasing. So therefore, if they're directly proportional, if reactant concentration decreases, rate decreases. In English, we're going to call that rate slows down. So the general format for a first order reaction, rate equals rate constant K, concentration of whatever substance to the 1. Now, as in most other math situations, the 1 exponent is optional. It is implied if you don't put it on there. But sometimes it makes it easier to go ahead and put the 1 in there. That way you just kind of cue yourself, especially at first, this is a first order reaction. So here we have this data from an experiment. So let's calculate the actual rate of the reaction. And then, or we're going to calculate the order. So first, let's take 2 pairs. Let's take these 2 this time. Why not? Okay, so we know that rate 2 over rate 1 equals K over second concentration to the N, K concentration of A at our first one to the N. So rate of our second one, 0.060, rate 1, 0.030. And if it helps you, to kind of make some arrows, do that. Rate constant K falls out. Okay, molarity per second, so that's going to fall out. Here, we'll put K in there. First concentration that goes with 0.6, 0.40. Put your exponent up there. We're solving for N here. N is the order of the reaction. Obviously, since it's under the title of first order reaction, I kind of gave it away, didn't I, right? Okay, so now, here, units fall out, K's falls out. That's a molarity, it's gone too. Okay, so 0.06 divided by 0.03, it's 2. You could probably see that, but just in case, I'm going to demonstrate it for you. So 0.4 divided by 0.2 is also 2, and then there's the exponent. You can use your logarithms if you want to, so you can undo this by taking log of both sides. So you know that the log of 2 equals n times the log of 2. Solve for n. N equals log 2 over log 2. Guess what? Log 2 over log 2 is 1. So this is a first order reaction. So when you're given data, you need to determine the order of the reaction first. Now, once we determine the order of the reaction, then we find the rate constant. The questions will ask you to do this. They'll say, what's the order of the reaction? What is the rate constant K? So now we know we write our rate equals K, concentration of A, to the first power. So again, units really matter here. So put in any pair. I haven't used this one yet. So my rate 0.015 molarity per second equals rate constant K 0.10 to the first power molar. I said do that and then I forgot. Okay, so now that's still 1. So now we need to divide by 0.10 molar. So divide 0.10 molar. So that means K is going to equal what is 0.015 divided by 0.1. So here I got a number of 0.15. Now what are the units? Here you have molarity in the top, molarity in the bottom. So there's no concentration here. There's only seconds and they go in the bottom. And so a lot of times I'm in the habit of just writing per second. You'll probably get like that after you've had physics. But so in a first order reaction, the units for the rate constant K are going to be like 1/seconds, or you can write it as seconds to the -1. Both of those are acceptable, and you need to be familiar with that notation when you're doing homework and answering questions.